In this video, I'll show you how to solve the ALEKS problem called distinguishing chemical and physical change. This problem is going to give us an initial sample of a substance. This is molecules being represented with these little spheres. Each sphere represents an individual atom. So for this particular molecule here, you can see there's kind of like two blobs merged together. That is two separate spheres, and that represents two atoms. So saying that we have this sample, it undergoes three different possible changes, and our job is to determine if the change is physical or if it is chemical or if it is impossible. Now, one of the things that you need to pay attention to in this problem is that it says the sample is in a sealed box. So that means that every single atom that you start with in the original sample, every one of those atoms has to be accounted for after the sample undergoes change, and also no new atoms can be introduced. So it says here no matter can enter or leave. It might be helpful for you to count up the number of atoms that you're starting with. Maybe not so much for this particular problem. It's a little bit easier compared to some of the other ones, but it's not going to hurt. So in my original sample, I have 2 atoms in each molecule, and I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 molecules. So I'm starting with 24 red atoms, whatever that red atom represents: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So after the change occurs, I need to end with 24 red atoms exactly. Nothing more than that, nothing less than that. And if there's any other atom, or if any atoms have been removed, the change is impossible, again, because it's in a sealed box. So if we take a look at change number 1, these molecules are containing 3 atoms. So this is a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So here we have 24 red atoms, which means that this is not impossible. We're going to rule that out. It's possible. For this one, this is an impossible situation because we have introduced these black atoms into the mix, and that's not allowed because the box is sealed. Also, because we've lost some of our red atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've lost 12 red atoms. We've gained 12 black atoms. That is impossible if the box has been sealed. Now over here we have molecules that have atoms in sets of 2 again. This is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So over here we have ending with 24 red atoms. And that means, again, that this is not an impossible change. This is a possibility of a change. So for change number 1 and change number 2, we need to decide if we're looking at a physical change or a chemical change. Let's do a quick definition of what those terms mean. A physical change is when we do not change the identity of the molecule or the atom. So there's no change in the identity. And in this type of problem, what that means is that the number of spheres, the arrangement of spheres in each molecule is not going to change. So if we start with a molecule that has 2 red spheres, in a physical change, we are going to end, also, same thing, molecules that have 2 red spheres. No more than that, no less than that. 2 red spheres or 2 red atoms. So in this problem, we're starting with molecules that have 2 red spheres. We're ending with molecules that have 3 red spheres. That is not a physical change. For here, we're starting with molecules that have 2 red spheres. We're ending with molecules that have 2 red spheres. That is a physical change. Now, a chemical change, that's the only thing that's left for this one, so we know that it's a chemical change. Let's define that, though. A chemical change is when something undergoes a change in identity. And in terms of a problem that is structured like this change in identity is going to be represented by a change in the number of spheres that are attached to each other in a particular atom, or just a change in the way the spheres are connected. The change in the way that the spheres are grouped together. I'm going to use that word, grouped or connected to each other. So in this problem, we're starting with 2 spheres that are grouped and we're ending with 3 spheres in a group, and that is a chemical change.